All right, this is 6.2, part 2, and we're going to identify the n, the sample space, the random variable, the probability of success, the probability of failure, and the probability of the random variable. Each child born to a particular family has a 0.3 probability of having type O blood. If this couple has 7 children, then what is the probability? Now, what is the probability that? This is just our information. This goes down to here. What is the probability that exactly 2 of them have type O blood? That exactly 3 of them have type O blood. So that's what it's doing. So n is 7, because that's the number of trials. The probability of success is 0.3. The probability of failure is 0.7. Remember, that is 1 minus p. Exactly 2 of them have type O blood. So that's p of the random variable equaling 2. And we learned that we go 7, choose 2, times the probability of success raised to the x value, times the probability of failure raised to the 7 minus 2, which would be 5. And then you plug that in your calculator, and the last video showed us that, so I'm just going to put the findings, which is 31.7%. Okay. What is the probability that at least 3 of them have type O blood? Well, we can't do that with this because it has more than just one value. So the probability that at least 3, that means that x would have to be greater than or equal to 3. So what we want to do is fill out our table. So 0, 1, 2, 3, 4, 5, 6, 7. These are the possibilities that I could have. No children having type O, 1 child having type O, 2, 3, 4, all the way up to 7 children having type O. Now remember, the probabilities came from this formula. Well, there's an easier way to find it, and so we're going to use this right here to find it. So let me show you where to find that. On your calculator, I'm going to move this over here so you can see it. Okay, so let's clear that out. We're going to go to second bars, which you see above there is distribution. We need to find binomial PDF. So we scroll and we find it right there, binomial PDF. So we hit enter. And then we've got to tell it n, which is 7, comma p, which is 0.3. Now, you don't have to do this part, but I find it easier. We want to store that in list 1. I'm going to hit enter. Now, there's my probabilities all right there, and I could write them down from that so you can see. So you can see them there, or I can hit stat edit, and they're also in list 1. So it's easier to read it from here. So .08 is the first one. 0.25 is the next one. Then 0.32. 3 is 0.23. 4 is 0.10. 5 is 0.03. 6 is 0 plus. And 7 is 0 plus, which means it's a little more than 0. All right, so that has greater than 3. Well, or equal to 3. So that would be this one, and this one, and this one, and this one, and this one. So we add those up. 0.23 plus 0.10 plus 0.03 plus 0 plus 0, which will give us, I think that says 36, or 0.36, which would be 36%. So 36% probability that at least 3 of the children would have blood type 0. Okay, now it says find the mean. Remember, mean was n times p. N is 7, p is 0.3, so 7 times 0.3 is 2.1. The standard deviation is the square root of n times p times q, which is the square root of 7 times 0.3 times 0.7, which gives us 1.2. And the range of usual values. Well, if I do it by percents, it's got to be less than 5% to be unusual. So less than 5% would be 5, 6, 7. So what would be the usual range would be from 0 to 4. If we were talking about percents, it'd be from 0 to 4. If we were talking standard deviation, then we have to say the mean, which is 2.1, plus 2 times the standard deviation, and then we do the mean minus 2 times the standard deviation. This one is 4.5. This one is -3. So the range of usual values would be from -3 to 4.5 if you were talking about standard deviation. Okay. So the next one. Number 9. Among employed women, 40% have never been married. If 10 employed women are selected at random, find the probability of the following. Remember, that goes down here. N is going to be our 10. The probability of never being married is 0.4. And then the opposite of that is 0.6. Exactly 5 have never been married. So that's the probability that x equals 5. It says show the formula. So that's that 10, choose 5. The probability of success raised to the x. And then the probability of failure raised to the n minus x, which would also be 5. Plug that into the calculator and you find 20%. 2 or fewer. So when it's like this, that means we've got to do our PDF. Our distribution. So from 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to use our binomial PDF. And that gives us 0.01, 0.04, I can't read them, so I'm going to have to do it on my calculator. So I'll show you how to do it again. Turn it on. Go back to the home screen. And we want to go second vars, find binomial PDF, which is right here. Put in your n first, which is 10. Then put in your p, which is 0.4. And then hit it. Oh, I didn't put it in list 1. So I'm going to store STO into list 1. Now I'll go to my stat and my edit. Alright, so it's rewritten them. So 0.01, 0.04, 0.12, 0.21, 4 is 0. 1, 2, 3, 4 is 0.25. 0.20, 0.11, 0.04, 0.01, 0 plus, and 0 plus. Alright, so 2 or fewer, so that would be the probability that x is less than or equal to 2. So here's 2, less than or equal to, so we added those up, 0.12 plus 0.04 plus 0.01, which would give us 0.17, which would be 17%. Okay, then at least 1, remember anytime it says at least, you're saying that the probability of at least 1 is 1 minus the probability of none. So this is going to be 1 minus 0.01, which is 0.99 or 99%. Okay. The mean is n times p. N was 10. P is 0.4. So 10 times 0.4 is 4. This is the square root of n times p times q, which comes out to be 1.6. So by percentages, less than 5% would be here. The 0.04, 0.01s, 0.0s there. So it's got to be from 2 to 6. So the range would be from 2 to 6 by percents. By standard deviation, we take the mean and add 2 times the standard deviation, take the mean and subtract 2 times the standard deviation. And you should get 1.2 and 7.2. Okay, if you feel like you got it, you don't have to listen to the rest. If you need more practice, I will continue on. Alright, number 10. Over a short period of time, it has been shown that a basketball player can hit .80 of his shots. Suppose that he shoots 11 shots, and then what is the probability of the following? That he hits exactly 8, that he hits 9 or more, or he misses them all. So our n would be 11. Our probability of success is 0.8 or 0.80. And q is 1 minus p, which is 0.2 or 0.20. Exactly 8 would be probability that our random variable is 8, which is 11 choose 8 times the probability of success raised to the x. The failure raised to the n minus x would be 23, and that comes out to be 0.2215, which is 22%. That he hits 9 or more, so that's the probability that x is greater than or equal to 9. So we would want to do our binomial table. So 0, 1, 2, 3, 11. Put it into the calculator. Remember, you go to second bars and you plug in, you find your binom PDF, you plug in your n, which is 11, your p, which is 0.8, and you should find that 1 through 4 are pretty much zeros, which are the 0 pluses. 5 we get 0.11, no, sorry, 0.01. 6 is 0.04. 7, I believe, is 0.11. 8 is 0.22. And I cannot read the other 3. I'll have to go look at those. Alright, so this is 0.08, this is 0.24, and 9 is 0.29, 0.22, 0.11, 0.04. Yep. Okay, so 9 or more, that means we have to add up these three. So 0.29 plus 0.24 plus 0.08. We add those up and we get 63%, which would be 0.63. What's the probability that he misses them all? That would be oh, it's different than what I said. The probability that he misses them all would be 0, or 0 plus. The probability that he hits at least 1 would be 1 minus the probability of none, which would be 1 minus 0. So that was two different problems. I hope I didn't confuse you. If he misses them all, so that'd be the probability of x equals 0, which would be 0 plus. If adding in an extra question where he hits at least 1, that's where we have to say 1 minus the probability of none, which would be 1 minus 0, which would be 100 or 100%. The 1 minus 1 would be 1. Alright, so n times p for the mean, which would be 11 times 0.8, which is 8.8. The standard deviation is 1.3. That's n times p times q. And the range of usual or unusual values would be from 6.2 to 11.4 standard deviation wise, and by percents 7 through 11, not comma, 7 through 11 would be by percents. Okay. And number 11. 1 out of 10 letters arriving at the post office nearest Graceland is addressed to Elvis. In a random sampling of 8 letters, what are the probabilities of the following? So if 1 out of 10 letters arriving at the post office is addressed to Elvis, that would be 1 divided by 10, or 0.10. That would be the probability of success, which leaves that to be 0.90, and there's 8 letters. So no letters are addressed to Elvis would be the probability of x equals 0, which is 8. Choose 0. 0.10, the success to the 0. 0.9 to the failures to the n minus 0, which is 8. And we find that that gives us 0.43, which is 43%. At least 3 will be addressed, so we have to do our table. 0, 1, 2, 3, 4, 5, 6, 7, 8. And so binomial PDF, which is 8, 0.1. Store it in list 1, and we get 0.43, 0.38, 0.15, 0.03, 0.0 or 0 plus, 0 plus, 0 plus, 0 plus, 0 plus. So at least 3, so the probability that x is less than or equal to 3 would be 0.03 plus 0.15 plus 0.38 plus 0.43, which equals 3.5%. Just 0. Okay, x, the mean, which is n times p, which is 8, mean 0.8. Square root of n times p times q is 0.85. The range of usual values is the mean plus or minus 2 standard deviations, the mean minus 2 standard deviation, 2 times the standard deviation, and we should get negative 0.9, 2.5. So that's by standard deviation. And then by percents, it would have to be from 0 to 2. Because if you look here, all of these percents are less than 5.05. All right, that is 6.2. If you have any questions, ask in class.